Hey folks, welcome back to my YouTube channel. So today we will provision a GPU machine and get some hands-on experience. I will be using Vast.ai as my cloud provider. If you want to know why I'm using Vast.ai, I'd recommend you go and watch my previous videos about why I'm picking my cloud provider as Vast.ai, and I actually worked around with a couple of other GPU cloud providers too. So you'll see my regions there. Once you are on Vast.ai, so click in console, and then once you click in console, it gives you an option to select a template. So in this template, you can select which OS you want, and there are multiple other options about the templates that they have. So some of the software is pre-installed, number of ports pre-exposed, and so on. So it's very use case by use case, and you can create your own template as well. But for this purpose, I'm gonna go with the default template. And then you will see your options here, right? So you can select your region. You have a number of GPUs, and you will see all the specs here. So I will just select one random 2 RTX 4070 GPU with 12 gigs of VRAM, and then the bandwidth is 434.1 Gbps. So let's rent that. And essentially that's it. You need to have your SSH keys uploaded here so you can SSH to the instance. So once you rent your instance, what you can do is click on your instances tab, and then you will see the instance will be creating. So I already have an instance that is created for my lab purposes. I will come back to this and also how you can SSH to the instance, but all you have to do is click and connect. It shows you the SSH options, and then you can copy that. And once you copy that, let's say, and then let's kill that session. Let's kill the session 2, and then let's go open a new tmux, actually vertical. Okay, so once you have the SSH command, you can directly SSH to the machines, and then you can see we have root access here, right? So the first thing I want to check is if I have NVIDIA-SMI here or not. Okay, so we can see that we have NVIDIA-SMI here. We will see the information about our GPU. So before coming to this, I kind of wanted to talk about a few things here briefly. So, to understand this flow here, let's talk about, the different components here, right? So let's use the analogy of a car. If a GPU hardware is an engine, then the driver here is like a gearbox, right? That connects to the engine. And then CUDA toolkit is like the tool that we use to control the engine. And frameworks like PyTorch and TensorFlow sits on top, which will use CUDA toolkit under the hood and then talk to the GPU for us. So from a very high level, we have a driver. So that is this driver here. So notice the NVIDIA-SMI and driver being on the exact same version. So these two get shipped as a same package. And then this driver is what Linux kernel uses to plug into the GPU hardware. And we use NVIDIA-SMI, the CLI tool, which will talk to the driver and give the information that we want, right? And then we see here the CUDA version is 12.9. So, CUDA is it's a compute unified device architecture. So essentially it's an architecture built by NVIDIA. Because of this architecture, we can use GPUs to do much more than just graphic processing. We can use its parallel processing powers to do anything that we want, right? So a brief flow of how things work would be you would write your Python code using frameworks like PyTorch or TensorFlow, and then that uses the CUDA APIs, which will send its information to the driver, and then driver will pass it on to the GPU hardware. So briefly again, driver makes GPU usable by Linux, allowing the OS to use the engine, which we know, and then CUDA exposes APIs and libraries, so application can send workload to GPU, so built by NVIDIA. Frameworks like PyTorch and TensorFlow use CUDA under the hood, so we don't have to write GPU assembly, and then it translates high-level commands to CUDA instructions. So we know NVIDIA-SMI reads information from the driver, it shows it to us. It's essentially a CLI tool that allows us to interact with our GPU. And then NVCC is the CUDA compiler, which will turn C++ code into GPU instructions. But we'll be using frameworks like PyTorch, so I won't really be using a lot of NVCC stuff. If I do NVCC --version, you will see that I don't have it installed, right? Because I will be using PyTorch for most of my stuff, but you can install it if you want. So the first thing that I want to do here is I want to ensure that I have Python installed, and let's check that. So okay, I already have it installed. So if you didn't have it installed, you know, you will see it installing by default. So after I have my Python environments ready, what I will do is I will create a virtual environment so that we don't conflict with the Python that's in the system. So essentially, you know, install Python 3 environment. Okay, no, sorry, my bad. I think let's copy this guy here. And then that's what I want. So let's create a virtual environment. And there we go. So now we're inside a virtual environment of Python. So all the packages that I installed will be in this virtual environment. It will not conflict with the Python in my system machine. I would recommend this approach, at least for now. So let's install PyTorch with CUDA support so we can use the PyTorch framework. So that's the command to install PyTorch. You know, you can I'm installing a specific version for my use case, but you see that I already had it installed. If you didn't have it installed, then it would just go ahead and do the clean install for you. So here I have two files. That's -lt or h. You'll see test.py and test2.py, right? So I will run this test.py first. So python 3 test.py. And then what this does is that it will check if CUDA is available in the system or not. And if it is available, give me the name of the GPU. So let's run this command here, watch-n1, and then NVIDIA-SMI. So essentially when you run watch-n1 command, what it does is that it will run that command every 1 second. So watch is not something that's specific to GPU devices. It's a Linux tool. You can use it for, you know, any other programs too. So here we will run our two Python programs and see the GPU utilization, right? So let's look at a couple of things that are important for us. We talked about the versions, we talked about CUDA as well. So let's talk about, you know, you see the indexing 0 and 1, right? So the GPU indexing starts from 0. For 2 GPUs, it will be listed as 0 and 1. So that percentage here is about the fan utilization. Right now, it's not been utilized. The temperature is 46 and 44. And then see this value here that says P8. So that's the performance metric. So if it's P8, it means the GPU is really idle. It's not doing anything. And then with P0 being it's, you know, fully utilized. So ideally, you would not want this situation. You would want your GPU to be utilized. And then the power utilization right now is 11 watts on one, and the other one is 13, with that being the maximum cap. And then this is the VRAM, right? So I provisioned the GPU where the total VRAM was 24 gigs. You can see that here, 24, but then it's per GPU, right? So each GPU has 12 gigs of VRAM and totaling to 24. So GPU utilization is 0% as expected. We haven't done anything. And then 3 things here, right? So ECC is the error checking code, which I talked about in my VRAM video. So that's NA. It's a feature that's available on data center GPUs. And then MIG is the same. MIG is similar feature. It's a multi-instance GPU. You get to slice up your GPU into multiple profiles. It's NA here as well, not available. And then the other option here is compute M dot, right? So when that option is set to default, what happens is when a process tries to use a GPU, it will be shared by default, right? So imagine, you know, you have 5 processors fighting for the GPU, then it will be shared to all 5 processors. But if that is set to exclusive, then only one process can use the GPU at a time. Until it's not fully done, it won't release it, right? So you might need something like exclusive when you are running an inference server. So let's say, you know, you want your inference job to complete without any delays. You want that to be your top priority. Then set it to exclusive so that your inference job uses the GPU fully, right? So and then here you can see the different processes running, the utilization, and so on. So what I'm gonna do here is, okay, let's look into the test.py code initially first, but I'll upload this code in my GitHub as well. So nothing too fancy here. Utilizes imports torch, utilizes CUDA. It checks is it available or not. If it's available, print the name. That's it. And then the other code I have here is called test2.py. So what we're doing here is essentially it's doing a matrix multiplication of it's doing a 15,000 matrix multiplication, right? So this kind of multi matrix multiplication is very, very heavy on CPU. So it would take ages for a CPU to complete this job, but GPU machines should be able to do this much faster. So let's see how that works. So for that, what I will do is I will run that in a loop so we can see the utilization over here. So let's go for I in, let's do 1 to dot 15. Actually, I think I already have a loop in my code. Oh yeah, so I have a while loop here, so I don't really need to define a bash loop. So let's go Python 3 test2.py. And the things that we're trying to look here is this one, right? GPU utilization, the VRAM utilization, and then we can look into this performance metric being changed as well. So Python 3 test2.py. Okay, so that should be running now. Okay, boom, there we go. So we have a new process here. That's the process ID 6111, and then that's the name of the process, Python 3. The current memory utilization is 3.6 gigs. So you see one of the GPU is utilized 100%, well, when the other one is 0%, right? So the memory utilization here is spiking, but over here it's not utilized a lot of memory. Same goes with power. So we are reaching peak power. So the fan is at 53% now. That's the GPU temperature. And then the performance matrix is at P2, right? But notice this, only this GPU is fully utilized. Like this one is not touched at all by that process. So these are the example of things that I want to learn, and I want to teach other people as well. And how do I utilize both of these GPUs then? Because this is not optimal, right? In a normal Linux situation, usually we have like a load balancer algorithms where you have two servers. We try to send the workload to both of them, keep both of them busy. Generally speaking, again, it's case by case. But in this situation, I would have preferred my job to be handled by both GPUs, so one of them does not go higher on temperature, or it does not peak on its utilization and it might crash or so on. I would have preferred the workload to be divided 50-50, but these are the things that we'll find out in the future. And yeah, I hope you guys learned something on this one. Thank you for watching. Oh yeah, I think the final thing here is that that GPU got provisioned here, and then see if you just click on connect option, and you will get the SSH command, so you can SSH directly into the machine. So yeah, thank you all for watching.